Good afternoon, everyone. My name is Café. I'm a master's student in Systems and Control, and right now I'm working on my thesis in the Control System group under the supervision of Thijs Donkers and Paul Padilla. And today we'll talk about energy-efficient coordination of autonomous vehicles in intersections. And I believe that the best way to show how an autonomous intersection will look like is with this video. So, just a funny video, but basically the idea is that when all the vehicles will be autonomous, they will be able to coordinate each other and they can cross all together in the intersection without crashing into each other. So let's consider just a little bit with more details how the intersection control problem works. So I believe that one of the main issues is actually the scalability, since depending on the number of vehicles that we have, the number of possible solutions will increase. It's a combinatorial problem, so the number of possible solutions will increase in an exponential way with the number of cars approaching the intersection. Moreover, we need fast solutions, since a vehicle takes more or less 18 or 12 seconds to actually solve the intersection, so we need to coordinate fast enough the vehicles before they will actually enter the intersection. Moreover, depending on what we want to maximize or minimize, so depending on our objective, the optimal solution will change. So, therefore, it's actually a pretty complex problem, and I decided to start working on it during my internship, where I considered a simpler version of it. So I considered just one autonomous vehicle intersecting with n human-driven vehicles. And I made two main assumptions. The first one was that all the vehicles are not allowed to turn, so they can just go straight. And secondly, the human-driven vehicles can either keep their speed constant, so equal to the initial velocity, or they will need actually to stop before the intersection if the traffic light turns red. My objective was to make it fast for real-time implementation and minimize energy consumption. This is still a relevant problem, since it can be related to some real-life scenario. For instance, of those of you who know Eindhoven, there are some intersections where there are exclusive lanes for the buses, and we can somehow control the velocity profile of the bus, and it intersects with some human-driven vehicles. So if we consider this problem, basically we have control input for the bus that is continuous, since we can control the velocity profile in time of the bus, and we have somehow a discrete input control variable for the vehicles, since we can turn the traffic light from green to red, so we have a binary variable to either stop the vehicles or let just go. So since we have some inputs that are continuous and some other that are discrete, this problem belongs to the mixed integer programming category. It is actually the hardest one that you can think about. And I solved this problem using the DOM optimization solver implemented on a MacBook Pro 2017, and it took more or less 2 seconds to find the solution, depending on the number of vehicles approaching. Here, I just reported some of the solutions, just to give you a feeling of how much the solution can change between each other, depending on the scenarios that we are facing. So in this case, I considered 10 human-driven vehicles intersecting with a bus. The cars have a speed of 32 kilometers per hour and the bus 31. Each of those boxes represent basically the time in which each vehicle enters and exits the intersection. So basically represent a constraint for the bus that can't enter the intersection, otherwise they will crash. So in this case, the optimal solution is to let the bus just accelerate a little bit and cross before all the other vehicles. On this one, I consider a very similar scenario, but with a completely different solution that can be a bit counterintuitive in terms of energy consumption, where I have still 10 cars, but I increase their velocity. And here you can see that the optimal solution is to let just one human-driven vehicle actually keep going at constant speed, then stop the other 9, let the bus cross in between, and then turn the traffic light green again and let the other 9 cross. So in conclusion, I managed to solve a real-life scenario problem that can be implemented in real time, since it was fast enough, that optimized energy consumption. My future work, that is actually what I'm working on my thesis right now, is to make the intersection fully autonomous, like the initial video that I showed, where in this case also turning are allowed in this case, and the objective is to minimize the energy consumption. Thank you very much for the attention.
Good pitch. Questions? So, how many smart intersections already exist? Do you know anything about them?
How many smart intersections like this one?
Yeah, not like this, because this seems to be the future still, but yeah, like at least some kind of intelligence in intersections.
Well, Well, for instance, here in Eindhoven already there exist some intersections where they basically optimize the time somehow. Basically, there are some traffic lights that know when there are cars approaching and where like pedestrian approaching. So there are already some kind of technologies implemented on the traffic lights. That means there will be the possibility to implement something also for the energy minimization. Since with also Wi-Fi and GPS connections, you can actually know when the cars are approaching and their speed. So you can actually use an algorithm to coordinate and see when to turn on or off the traffic lights.
Thanks.
So yes, it's step by step we're getting more intelligence indeed, but that's relative intelligence if you compare it to this one. Because in this one you have the cars, of course, that might share their position and communicate. Then the bikes come in, and we have to make also the bike connected as well in the future, you foresee, or what do you do with pedestrians or street dogs?
Yeah, indeed. I mean, autonomous vehicles have like many parts that can be need to be controlled actually. So one of the parts is actually the intersection, so the coordination between each other. But then there will be also interaction with what are basically disturbances somehow. So humans, so pedestrians and bikes. So there are many other things that need to be taken into account before implementing something like that.
But the more intelligence, the better it will run.
Yeah, maybe one observation, if you look at companies like Swarco, etc., they're working on this, and one of their dilemmas is they have to make also the algorithm predictable, right? Since the cars have to know maybe 9, 10, 12 seconds ahead what it will be so that they can adjust. So how do we deal with that in your research?
Well, so actually how to adjust beforehand.
Yeah, you cannot switch the light at the last second before the car is there, so you have to make up your mind 10, 20 seconds before.
Yeah, indeed. So actually I consider that in this case I'm not considering the very first second before entering the intersection, but I'm taking into consideration that there will be like some space, so basically I will know some time ahead that the car is coming, how many cars is coming, and the algorithm will have time enough to actually obtain a solution and then decide to switch the traffic light in order to not have like switch at the very last time and then you have to brake like as much as you can to not crash.
Have you been to the ITS conference in Eindhoven these days?
No.
Because that's where all the Swarcos and the Dinics are. And they're quite heavily interested in this kind of stuff, how to make their traffic lights better. And I hate traffic lights.
Yeah, but it's mostly ITS. So
This is the real ITS stuff that was just in Eindhoven. I think it stops in 20 seconds. It ends. So we can go there. But if you want to, we know all these Dinics. Dinic is the big Dutch one, and Siemens also do a lot here in the Netherlands. So if you want to link to them, they're quite interested probably to talk to this. I think there's me or anyone else here. Any last question? Yes. No, thanks. Keep up the good work.
Thank you very much.